Okay, let's get started with the first part of section 13.6, the normal curve. First, we're going to go over different names of particular types of distributions. And the graphs are really very helpful in understanding why they are named, what they are named. A distribution is a way that you graphically represent data. We've gone over that in an earlier section. This first graph is called a rectangular distribution. You'll notice that it's shaped like a rectangle. All the observed values occur with the same frequency. So they're the same height. The second type distribution is called a J-shaped distribution, and you can see how they named it a J shape. This is for those of us who are dyslexic. There's another J, right? The frequency is either constantly increasing, notice it's going up at the same rate, or constantly decreasing, going down at the same rate. And it forms a J distribution. Next, we have a distribution that's called a bimodal distribution. Bi, of course, means two. Mode means the most frequent, right? The mode, we covered that earlier. So if you'll look at this graph, you will see that there are two peaks in it, and they don't occur side by side. There's a gap between them. Two non-adjacent, not side by side, two non-adjacent values occur more frequently than any other values in a set of data. So in this set of data, you have two peaks that are separated, okay? Bimodal. Okay. The next type distribution is called a skewed distribution. This has more of a tail on one side than the other. This end that's sticking out over here is called a tail. Over here, it's the tail right there, right? The tail is the part that's sticking out, and so we have kind of a hump and then a tail. Here the tail comes first, and then the peak. Most of the data is, the blue represents the data for the distribution. Oddly enough, when the hump is on the left and the tail is to the right, we call this skewed right, and that's what those little words there say. Skewed to the right. Here, when the tail is sticking to the left, we call this skewed to the left. That's, again, what your handout says. Smoothing the histogram of the skewed distribution to form curves. We have a curve that is skewed to the right. And here we have a curve that is skewed to the left. The relationship between the mean, median, and mode for the curves that are skewed to the right and to the left is listed as follows. So I will go over this. Those are rather small. I don't know if I can get any closer for you with my camera here. It has a broken neck, so I have to tape it to my computer. It makes it a little tricky. Okay, let's see if that will stick. Okay. So on the curve that is skewed to the right, we notice the mode is going to be the highest point. This is the mode right here that comes first. Next, we have the median. That's the middle of the data. We're using our measures of central tendency now. And finally, the mode. So that is always the order they will be in a skewed right distribution. In a skewed left distribution, the first thing we see is the mean, followed by the median in the middle, and the mode at the highest peak of the distribution. Okay. So finally, we have a few examples to identify what type distribution would best fit this. I will read the instructions here. State whether you think the distribution would be normal, J-shaped, bimodal, rectangular, skewed left, or skewed right. And the first thing we're supposed to tell is the wear mileage of automobiles tires. Okay, they should wear out pretty evenly. Very few will wear out at the beginning. A lot will wear out at around the warranty limit, somewhere around there. And then some will even make it further than that. So this distribution would go kind of like this. We would say that a normal distribution fits this. Now, we haven't really talked about normal. That's going to come up in just a second. But you will see it will have this symmetric shape about it. Okay. I might should have done it first, but it doesn't matter. The numbers resulting from tossing a die many times. If you roll a die, I don't know what they say. They usually say rolling a die. If you roll a 6-sided standard die, like we talked about in probability, if you do it enough times, you have an equal likelihood of having a 1, a 2, a 3, a 4, a 5, a 6. So if you graphed this, your bars would be, if you went long enough, about the same height. So we think that a rectangular distribution best describes this situation, set of data. Okay, part C, the number of people per household in the United States. Okay, we know that to have a household, you have to have at least one, right? So we start out with this. We're going to have distribution that's going to peak somewhere around the average family size, and then get smaller and smaller. We're less likely to have families with 23 people living in the same house, right? So it's going to go down as you get farther. So it'll have a tail on the right, so we call this skewed right. Didn't quite leave enough room there, but that will work. And finally, part D, the height of a sample of college freshmen where there are an equal number of females and males. Okay, as we record the heights, we won't have a lot that are at the short end, right? And it will increase as we get toward the average height. Then when we get to the average height of females, there should be a peak around the average, right? And the average height for men is several inches above that, so we should have another peak after that that represents the male's average height in the class, and tapering down as we go. Okay, so this should be a bimodal distribution. Okay, you will have some of my MATLAB questions like this, potentially on the test too. Example 2. In a distribution skewed to left, which has the greatest value, the mean, the median, or the mode? You may want to put this on your note card if you're having trouble remembering it, but we're talking about a distribution that is skewed left. The tail is over on the left. Remember, the highest point in this distribution is the mode, and the median is going to be right in the center of where we have half the data above and below that median. And the mean is going to be right down here somewhere. I'll call that mean. These values that are way out here in the tail will pull the mean down. Okay. So in this particular problem, it says which has the greatest value. Greatest value is the mode. Okay, let me tip the camera there for you. And the smallest value of those three is the mean. Very well. We will conclude this first part of this lecture, and we'll pick back up with the normal distribution and z-scores.